see 6.1. Polygon angle formulas. Make sure that we all have the same idea about what a polygon is. So we decided in our opener that it has, it's a shape. We can also call it a figure. We'll just say a shape with 3 or more sides. And we decided that all the sides needed to be straight. So the sides are segments. We decided it needed to be closed. And those are the main things. 3 or more sides are straight, and it's closed. I'm going to add one thing because sometimes you need to be careful with this. Is the sides meet only at vertices. So only at the corners. So the sides don't cross each other. And we did a really good job of coming up with that on our opener. Then we worked on our activity, and we decided that the sum of the interior angles of any polygon is n minus 2 times 180 degrees, where n is the number of sides. And we went through this process of dividing the polygon into triangles, and that's where this 180 degrees comes from. And we decided there were always 2 less triangles than how many sides we had, and that's how we came up with our formula. So that's our first big formula for chapter 6, is this n minus 2 times 180. And I just want to draw another picture here really quickly. So we are saying the interior angles. So if we just have some polygon like so, this is what we mean by an interior angle. It's the angle on the inside. We'll talk about exterior angles today also. All right. We good here? I wanted to back up really quickly. What does the prefix poly mean? What is it? Someone? Many. And do we know gon? Gon actually is from angle. It's Greek, from Greek for angle. So we think of a lot of sides. Polygon, the base of the word means many angles. And polygons have a lot of sides, more than 3 sides, and they also have a lot of angles. All right, so then we went further with our activity, and we decided that we could find the measure of one interior angle. So the measure of one interior angle of a regular polygon is, and we decided that all we needed to do there was divide this n minus 2 times 180 by however many sides we have, because all of them are the same, and n is the number of sides again. So the n minus 2 times 180 is all of them. divide by how many we have, and that tells us how many degrees are in one of them. And let's make sure that we all remember, what do we mean when we say the polygon is regular? Sides are the same? And what else? Yeah? All the angles are the same. Nice. So the sides are all the same length, the angles all measure the same angle measure. All right. We good there? We also can figure out some stuff. This next one is I gave us on our sheet the other day. The sum of the exterior angles of any polygon is 360 degrees, no matter what. And let me draw a picture here so we know what we're talking about with exterior angles. So for exterior angles, we talked about exterior angles with triangles. What we do is we extend a side at each vertex. So this is an exterior angle. This would be an exterior angle. This would be an exterior angle. So it makes sense that that they would add up to 360, because if we think of starting at this vertex and walking along this side, we're going to turn through that exterior angle, walk along that side, turn through that exterior angle all the way around, so we end up walking all the way around, and we're facing back the same direction that we started. So we've turned through 360 degrees. And now we're going to be able to find one exterior angle for a regular polygon. Well, all of them together are 360. All of them are the same. So what are we going to do to find one of them? Divide by the number of sides again. 360 divided by n. N equals the number of sides. So the exterior angles together are always 360. If we have a regular polygon, all those exterior angles are the same, so we divide by the number of sides. So those are our four main polygon angle formulas. Now in problems, the words that we'll look for, kind of keywords, if we're talking about one, it will say an exterior angle. It might say one exterior angle, a angle. Something that tells you they're talking about one. Sum, if we're looking for the sum, it will say all, or together, or total. Something like that that means all together. So that's what you're looking for to tell when you're going to use one versus the other. All right, so what I want to do is go through a couple of examples, the kinds of problems that we'll solve using these formulas. Any questions on our formulas? All right. So the first example is very similar to problems that we did with triangles. So I'm going to draw a shape like so. All right, and folks, if your phone is out right now, it should not be. It should be away. If we can't do that voluntarily, we'll have to work on other steps to make sure that happens. All right. So there's our picture, and the problem says find x. Well, the first thing we should do is look at this picture and say, well, how many sides do we have here? 5 sides. So we know it has 5 sides. What do all the angles, all the interior angles add up to in a 5-sided shape, pentagon? 540. If we don't remember, that, we can say 5 minus 2 times 180 equals 540. Well, what does this mark tell us? Yeah? 90 degrees. So here we have a 5-sided shape. We have all the angles but one. Just like the problems we did with triangles when we had all the angles but one in a triangle. What did we do to solve that? Add them up and then do what? Subtract from 540 now instead of 180. Exactly the same problem. And this would be the same for any polygon that we had. If we want to find one angle, add all the rest up and subtract from whatever the total is that we know the angles are inside the polygon. So if we wanted to write an equation, I would say 105 plus 95 plus 90, this is how we're, plus x equals 540. So basically what we're going to do is add all these up and subtract it from 540. So when we add all those up, we get 390 plus x equals 540. So we're going to subtract 390 from 540. And x equals, when we do that, we get 150 degrees. All right, questions there? All right, let's look at another one. So this problem is, what is the sum of the interior angles of a decagon? So first off, sum. What is that telling us? Is that one of them or all of them? All of them. Sum means all. What's a decagon? 10 sides. Decagon is 10 sides. So our sum, we know from our formula, 10 minus 2 times 180. So we get 8 times 180, and 8 times 180 is 1,440 degrees. And if this were a regular decagon and we wanted one of the interior angles, what would we do? Divide by 10, and we get 140. So let me say We've got this. What would be the sum of the exterior angles of a decagon? $360. The sum of the exterior angles is always 360, no matter how many sides it has. All right, let's look at, we're going to do a couple where we kind of work the problem in reverse. So we have the interior angle. Of a regular polygon is 140 degrees. How many sides? All right, so is this question asking us about all of them together or one? It tells us one angle is 140 degrees. Well, don't we have a formula for one angle in a regular polygon? Yeah. So we're going to say that one angle, 140, equals n minus 2 times 180 divided by n. And then this is an algebra problem. We're just trying to find n. So to solve for n, what's the first thing we do? What do we do? Multiply by n, right? We want to get that n out of the bottom. So I'm going to, I thought you said by 10. By n. Multiply by n. So times n, and I'm going to put the multiplication there, just so it's in the order that we usually see it. So when we multiply by n, those cancel, and I get 140 n. And what do I need to do here with these parentheses? Distribute. So we're going to multiply that 180 in there. So I get 180 n minus, because it's minus sign, 360. 2 times 180 is 360. I want to get all the n's together, so I'm going to subtract 180n, and here I need to be careful. 140n minus 180n, negative 40n equals negative 360. And now I can divide by negative 40. And I get n equals negative 360 divided by negative 40 is 9. So what is this thing? How would we name it? 9 sides? Do we remember? Nonagon. We have 9 sides. What would it tell us if we went through this problem and we got that n equals 7.2? You made a mistake somewhere. We can't have a fraction of a side. So with these problems, you should come up with a whole number. All right, I want to look at one more example. The exterior angle. Of a regular polygon. Is 30 degrees. How many sides? So is 30 degrees, is that all of them together, or is that one of them? That's one. The means one. Well, don't we have a formula for one exterior angle of a regular polygon? Yeah? One exterior angle is 360 divided by n. Almost the same kind of problem that we did last time. Going to follow the same steps, right? We want to solve for n. So I multiply both sides by n. Those cancel. I get 30n equals 360. Divide by 30. And n equals 12. So the angle, one angle is 360 divided by n. One side is 360 divided by the angle. Or the number of sides, sorry, the number of sides is 360 divided by the angle. What would we call this one? Do we remember? Did we talk about that? We didn't? Okay, we'll talk about that in a second. All right, I want to show you a little trick, though. Here is one vertex of a polygon. There's an exterior angle, and there's an interior angle. So let's say this is this polygon, 30 degrees. How are these two related, these two angles? They're supplementary. They add up to 180. So the interior and exterior angles are supplementary. So sometimes that can help you kind of as a shortcut to solve problems. So if we figured out that the exterior angle of this 12-sided polygon is 30 degrees, we can figure out the interior angle by subtracting from 180. So 180 minus 30 is 150. So one interior angle of a 12-sided polygon, regular polygon, is 150 degrees. So sometimes that can help you shortcut some work, is realizing that the interior and exterior angle are supplementary. Because sometimes, often, it's easier to find the exterior angle and then use that shortcut to find the interior angle. So instead of using the more complicated formula, here we could have figured out the exterior angle and then used this formula. So sometimes that's a way. All right, does someone have a question? No? Okay. All right, I want to make a little chart. We talked about this a little bit when we did our activity. So the polygon, the number of sides, and the interior angles. All right, so what's the smallest polygon that we can have? Triangle. Remember we had 3 or more sides? So polygon, triangle, 3 sides, and the interior angle, 180 degrees, interior angles. What's the next polygon, next biggest polygon? A square is a type of that kind of polygon. What is it? Quadrilateral. Quad just means 4, so quadrilateral. So quadrilateral is the only polygon that has a separate type of name. 4 sides and the interior angles? 360. What's the next one? 5 sides. What's it called? Pentagon. And all the angles add up to 540. And remember, we're going up by 180 each time. So you can figure it out that way. The next one, hexagon. 6 sides and interior angles, 720. Next one up, do we remember that? A heptagon. Or we said a septagon was okay. 7 sides. What are the angles add up to? 900. What's the 7th month? July? Yeah, it should be September. Right. The Romans switched around the calendar. What's the next one? Octagon. 8 sides. And what does that add up to? 1080. And we just talked about the next one, right? Nonagon. October is the 10th month. Same thing. Nonagon, 9 sides. Do you remember what that one was? 1260. 10 was decagon. 10. Is it in 1440? What is it? 1440? And this is 1260? Okay. I was taking you all's word for it. And that makes, so yeah, if we go up by 180 there, that makes sense, right? Okay. Do we know what the next one is called? No. Most of the others have a pretty boring name. An 11-sided polygon would be an 11gon. 12-sided one does have a special name. A dodecagon. And the rest are pretty boring. 13 gon, 14 gon, 15 gon. Until we get to 20. And the 20-sided shape is an icosadon. Not don-gon, icosagon. So that's 20. And if you play D&D, your 20-sided die, your D20, is an icosahedron. All right, questions there? Now sometimes you will be asked, the question will say a 9-sided polygon, da, 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 da. Sometimes it'll say nonagon. So we need to be able to translate both descriptions of a polygon. All right. So once I give you the homework, we're gonna I'll get the whiteboards out. We're gonna do some whiteboard practice. All right, there's that.